Okay. Good evening. Can you hear me?
Yes, sir.
Okay, very good. So, class, we saw up to question number 16. So I thought we'll continue from there. 17. So question number 16. Yeah, I remember doing this momentum. Stone dropped from a height. So I asked you to do page number 234. Okay, so you should have tried it. If you have tried it, I'm sure you will be learning more in this class. Okay, the force F acting on a particle of mass m is indicated by the force time graph shown below. The change in momentum of the particle over the time interval from 0 to 8. So I think in the last class itself we talked about this. F is equal to mv minus mu divided by delta t. So if they are given force and time, then this is like F into delta t. So that means the graph area under the curve will represent F into delta t. But then they are asking you to find the change in momentum. So as you can see, this is nothing but change in momentum. So if you understand this, this is a very easy problem. So that means this will be half base into height. So 6 into 2. So this will be 2, so plus 6. This will be 4 minus 2, it will be 2, 2 into 3, 6. So since it is in the negative side, you have to take minus 6. This area, it will be 8 minus 4, so it will be 4 into, I'm not sure, I saw that the solution is not correct. So I think the diagram is having some trouble. So let me check that. Yeah, I think the diagram is wrong. So let's take it up to 3. So that means 4 into 3 plus 12. So that means 6 and minus 6 will cancel. So plus 12 is your answer. So if I add all of them, you'll be getting plus 12. Okay, so the question was having some error. From the solutions, it looks like they should have given up to this 3 point. A particle moving with velocity is acted by three forces shown by the vector triangle. The velocity of the particle will be, so you can see that something is going this way, and then this way. So that means if I start here, the net velocity will be 0 because it is coming back to the same point. So since, sorry, force, right? So it's not a V net, it is F net. So the force is 0. So since force is 0, acceleration is 0. Since acceleration is 0, V will be constant. So velocity remains constant. Connected bodies means mostly you will get a lot of rope lift problems, rope problems. Okay, I asked you to go through the handbook also. So those who are serious about your NEET, you should have gone through the handbook and clarify your doubts. If you have any doubts, you can ask me. Monkey is descending from the branch of a tree with constant acceleration. So let's say the tree is like this. It's a tree, and maybe it's a big branch like this. So that's the tail of the monkey. So descending from the branch. So that means descending means coming down. Acceleration, constant acceleration. If the braking strength is 75% of the weight of the monkey, the minimum acceleration with which monkey can slide down without breaking the branch is. So braking strength is 75% of the weight of the monkey. So that means, what this means is, if the without moving, if it was hanging like this, 75% the weight itself will break the um, this branch of the tree. So that means the tension here, so T is equal to 75% of the mg. So this itself will break this. So that means 3 by 4 mg. So this is the maximum tension it can take. Now since it is descending down, the scenario will be slightly different. Here also I should have said 75%. So here the tension is acting upwards in this string or in the rope. Mg is acting here. So and this is sliding down with an acceleration A. So always remember, in mechanics the most important formula is sigma F is equal to ma. So if you know this formula, you can do 90% of the problems. So T minus mg is equal to, since it is coming down, don't forget, should be minus ma. So they're asking you to find the acceleration, minimum acceleration. So that means they're asking you to find the A value. T maximum, the maximum tension you can put on this thing is 3 by 4 mg. So that means 3 by 4 mg minus mg is equal to minus ma. This will be minus 1 by 4 g, 4, 3 minus 4, so 1 by 4 mg minus ma. Minus minus cancels, cancels. So a is equal to g by 4. Any doubts? So they are given the maximum tension it can withstand separately. So we have to incorporate this concept, this data into this concept. Okay. Again and again and again we are going to use this, so become comfortable. As we do 2 or 3 problems, I am sure it will become easy for you. Mass of 1 kg is suspended by a thread. It is lifted up with an acceleration 4.9, lowered with an acceleration, so ratio of the tension. So that means they are giving 2 different situations. Maybe there is no fixed this thing, you are pulling the rope, something like that. So here also do the same thing. Tension is acting upwards, mg is acting downwards, acceleration lifted up with an acceleration a. Here they said tension is same, mg is same, but now the acceleration is downwards. So since it is a totally different scenario, we have to take this as T1 and T2 because mass is same, g is same, but T1 and T2 are different. And acceleration is also same, okay, 4.9. That means again the same old concept, sigma f is equal to ma. So T1 minus mg is equal to ma. So T1 is equal to, always this will come on this side, so it will become added up, meaning the tension will be higher when it is pulled upwards. It will become g plus a. When it is pulled downwards, or lowered downwards, it will be minus ma here because it is coming down. So that means T2 is equal to, this will come here, so it will be m g minus a. Okay. So if you are wondering where to study these concepts, I'm sure you have studied this in your laws of motion, Newton's laws of motion concepts, but you can always refer to the handbook. Okay. Compared to your textbook, I'm sure it will be much more concise and very quick to refer. So very important concepts are documented here. It's your responsibility to study it properly and bring the doubts. If you have any doubts, we can discuss that. Okay. Pushing or pulling, which one is easier? 2 masses in contact, 3 masses in contact. You are going to get a lot of problems based on this. I given some example also, right? Many students used to complain that they are understanding the theory but they don't know how to apply it in the problem. So that's why this example was given. Then this is a very commonly asked question. You will come across this. This is also a very commonly asked question. 1 mass on the table, 1 mass on the hanging out in the pulley. And this one, just now we did this monkey. monkey problems, right? So going upwards and going downwards, plus MA and minus MA. So everything is documented properly, right? So this entire page is, T minus mg is equal to ma. So here it will get added up, here it will get subtracted. So if you understand this, it's not so many different problems. It's all based on the same concept. Okay, sigma f is equal to ma. So if you understand that, it's a easy, very easy chapter. That's all. So I think they're asking you the ratio of the tensions. So T1 minus T2 is equal to M and M will cancel, G plus A will be 9.8 plus 4.9 divided by 9.8 minus 4.9. So this will become 4.9, 3 times 4.9, this will be 4.9, so I think it will be 3 is to 1. So 3 is to 1 will be the answer. Okay, so do that. 9.8 is nothing but 4.9 into 2, so you can take this as 3 times 4.9. This will become 4.9, so that means it will become 3 times. Okay, any doubts? Very, very simple. I'm telling you, many of the solution books, they don't give you proper diagrams. Okay, without looking at this diagram, how are you going to know that, okay, this is going upwards and this is coming downwards, and you have to understand that you have to do this equation separately and this equation separately, right? So many solution books, they confuse you a lot. Instead of giving clarity, they confuse you a lot. So books will help you, YouTube videos will help you, websites will help you, but you have to do it and bring the doubts to the class. Only then you will be completing the circle. Just now I told you, you will get these kind of problems. Okay, very, very easy problems. Two blocks, 5 gram and 10 gram, are hung vertically over a light frictionless pulley as shown. What is the acceleration of the masses when they are left free? So you can see this is 10 gram, this is 5 gram, which means it's going to come down like this. And this is going to go up like this. Now listen carefully, very, very important concept. Since they are connected with a one single rope, if this is moving at 5 meter per second, this will also be moving at 5 meter per second. If this is changing to 10 meter per second, this will also change to 10 meter per second. So that means always remember, whenever there is only one rope, this A is going to be same and the tension is also going to be same. This tension here and this tension here are same. They are not different. Okay. If you compare it with the previous problem, there we were doing completely different cases, different scenarios. Here it is one single problem. And then each body you have to draw free body diagram for M1. Tension is pulling upwards. So why, sir, I should put upwards means something is pulling it upwards. That's why it has not fallen down. That means you have to imagine that there is a tension acting upwards. Okay, if you have difficulty, let me know. Otherwise, a simple explanation is it has not fallen down, which means something else is holding it up. That means most important formula in mechanics, sigma F is equal to ma. So T minus m1g is equal to m1 into a. Free body diagram of m2. Free body means you are freeing the body from the rest of the masses and you are showing only the forces involved in that particular object. So you see these are the forces and this is the effect. So this is called cause and this is called the effect, cause and effect. So I would say cause and effect are the result. Okay, because of the forces, this is accelerating with the acceleration A. Again, same story, tension T, M2G, it is accelerating downwards, and don't forget the minus MA. So sigma F is equal to MA is the most important formula in mechanics, cause and effect. So T minus M2G is equal to M2A. And I told you don't forget the minus because downwards. Many of you will make this mistake. All these things you will do it. You will make the mistake of not putting the minus, which means everything will go wrong. They are asking you to find the acceleration A, which means I should eliminate T. If they asked you to find T, then I have to eliminate A. So that's simple mathematics. So you should know which one to eliminate and which one to keep. So T minus M2G is equal to minus M2A. So I said I'm going to eliminate T. So that means I'm going to change the signs. M2 minus M1 into G is equal to M1 plus M2 into A. Actually, I could have directly put this 5 gram, 10 gram here, but sometimes they may not give you this values, and they will give the values in options in terms of M1 and M2. So in that case, also you should know how to do algebraic problem instead of the numerical problem. So A is equal to M2 minus M1 divided by M2 plus M1 into G. M2 is 10, this thing is 5, so 10 minus 5, 10 plus 5. So 10 minus 5 divided by 10 plus 5 into G. 5 divided by 15, so that means it will be 5, so 3 times, so G by 3. So G by 3 is your answer. Okay, you see things you might be thinking that it's very difficult problem. It's not difficult. Okay, very very simple problems. If you know how to do ABCDs, I'm sure you can do difficult ones. Okay, so these are all very easy ones, but once you do these things, I'm sure you can do little more difficult problems. Okay, so it's all just a matter of practice and consistency, whether you are consistent in your work or not. If you're not consistent, okay, you are coming for a class, one class, and then 1 month you don't come, then you just come for a visit like like a guest. Obviously you will not learn anything. So be regular in the classes and clarify your doubts. Any doubts? Can I move on? A lift weighing 1000 kg is moving upwards with an acceleration 1 meter per second square at tension in the supporting cable. Same old diagram. Tension is what is asked, 1000 kg, so mg is given. Acceleration upwards, so a is equal to 1 meter per second square. So very simple, sigma f is equal to ma t minus mg is equal to ma So T is equal to mg plus A. I told you whenever it is going upwards, the tension will be more. Whenever it is lowering downwards, the tension will be less. It will become G minus A. So mass is 1000, G is 9.8 or 10. So 10 plus 1, 11,000. Or I think they have taken 9.8. So let's take it as 9.8 here. So 9.8 plus 1, it will be 10.8, right? 10.8 into 1000. So 10.8 into 1000. So 10,800. Yeah. Monkey problem, I told you will get the monkey problem very often. Rope will not break when a mass of 25 kg is suspended. So that means they are given the, indirectly they are given the maximum tension. So that means up to 25 kg that rope will not break. So that means tension is here and this is mg. So beyond that, if I put any mass, this will break. So that means T maximum is equal to mg. Remember, this is not the problem which we are actually dealing with. They are just given a indirect information to confuse you in between. So it's your duty to recognize it. Okay, so it's your talent to recognize that this is a separate information or standalone information. So 25 kg is the maximum. So that means it is 250 Newton is the maximum. Now you have to apply this in the actual problem. What is the maximum acceleration with which the monkey can climb up along the rope? So that means that's a monkey. Tension in the rope is T. Mg is acting downwards. It is accelerating upwards. That means sigma f is equal to ma. In the exam, you don't have to do this. You can directly do T is equal to mg plus a. Okay, if you remember the basic concepts, you can directly do it. Every time you don't have to write all the steps. So monkey mass is 20 kg. G is 10. Maximum acceleration, so that means A. T max, if this is maximum, this should also be maximum. If you go beyond this, it will break and the monkey will fall down. So that means 250 is the maximum. So 0, 0 cancels, so 250 by 10, sorry, 25 by 2, 12.5, 12.5 minus 10, it will be 2.5. So A is equal to 2.5 meter per second square. Yeah, very simple, very easy. Okay, 25th one is completely different problem and slightly confusing, so please pay attention. Block of mass m is placed on a smooth wedge of inclination theta. So that means block of mass m is kept here. The whole system is accelerated horizontally so that the block does not slip on the wedge. So listen carefully, this is a wedge. Okay. So if I push the wedge here this way, obviously this will slide down. Only if I push the wedge this way, then this will be sticking to the wedge, this mass, if I accelerate quick enough, right? If you are having trouble understanding this, very simple. Imagine that this is your car and this is your passenger. You are sitting here. So when the car is suddenly accelerated, the passengers get pushed backwards. You will be getting pushed backwards. So that is what you have to remember here. Not during constant speed, only when you are accelerating, when the car is accelerating. So this is the underlying principle. If you don't know this, you cannot do this problem. So that means you know that mg is acting downwards here. Normal reaction is acting this way. When the wedge is accelerating, the whole system is accelerated horizontally. So that means wedge acceleration is A. If I say the car is accelerating with an acceleration A, the passenger will get pushed backwards with an acceleration A. We call this as pseudo acceleration or pseudo force. That means because of this wedge acceleration, this will be pulled backwards with an acceleration m into a. So we can call this as F is equal to ma. Usually what we will do is we will write this as mg cos theta this way and mg sin theta this way. But you can do it by two different methods, right? So this is the main diagram. You can do it by two different methods. So method 1 is easier. I will show you both the methods. As I have been telling you, learning more than one method will improve your understanding and concepts and confidence. So I would say if this is theta, this is also theta. Why? Because if this is theta, this should be theta. If this is theta, this is also theta. Okay, so as you keep on doing this problems, you will get the idea very easily. If you are not convinced, I can explain it one more time. If this is theta, this is theta. Why? Because this is 90 minus theta. If this is 90 minus theta, this should be theta. If this is theta, this is also theta. Okay, because it looks something like this. This is theta, this is also theta. Okay, so as I told you, method 1 is easier. Normal reaction, I am going to write it as n cos theta and n sin theta. So I am writing this n into two different components. Why would I do that? Because listen carefully, so that the block does not slip on the wedge. So that means the block is not moving at all. That means, what does that mean? You should know that sigma f is equal to ma. Ma is 0 because it's not moving, which means this minus this, these two should be equal. Okay. You can directly write this as f is equal to n sine theta. I can do that. But if I want to confuse you or if I want to explain a little more, I can say that sigma f is equal to ma. Since it is not moving, this becomes 0. This ma is different, right? With respect to the block, it is not moving. So that means I am talking about f minus n sine theta is equal to 0. F is ma. This ma and this ma are different, so understand that. Okay, so that means this and this will be equal. Another thing is n cos theta is equal to n cos theta is equal to mg, the vertical direction. That means n is equal to mg by cos theta. That's all. So read the question. The force exerted by the wedge on the block. So when we say force exerted by the block, okay, this is like a pseudo force because the passenger is getting pushed backwards. Nobody pushed him, but still, he experiences some force, or it feels like somebody pushed him because of the car moving forward. Okay, so that's why this is called pseudo force. So this n is the normal reaction. So the normal reaction is what they are asking. So this is a bit confusing. The force exerted by the wedge on the block. You may think that it is F, but it's not the F, it is the normal reaction they are asking. So that means n is equal to mg cos theta is your answer. Sometimes they may ask you what is the minimum acceleration with which the wedge should move so that the block does not come down, which means you have to use this equation to find. So in that case I would have said ma is equal to n sine theta. So a is equal to n sine theta. In place of n I can put mg by cos theta. Sine theta here, then divide by mass here. So mass cancels, so I'll be getting g tan theta. But in this problem they didn't ask you to find the a, right? So you don't have to worry about this. But in some problems they'll ask you what is the acceleration so that the block does not fall down. What this means is as the gravity increases, the acceleration will also be increasing. For acceleration, why would it increase? It is a constant. Well, if you are thinking about only Earth, if you are thinking about the surface of the Earth, then yes, g is constant. But suppose if the problem was given in Moon or Jupiter, then the g will be changing. So in the Moon, the g will be less, 1/6 less, which means the acceleration to keep it attached to the wedge will also be less. Similarly, theta, you see, this is theta. As the theta gets bigger and bigger, it will become vertical. As it becomes vertical, holding the block in the vertical position is going to be very difficult because it will fall down. So that means if it is vertical, then you have to accelerate much more higher, very, very high speed, like a rocket speed or something. Only then this will be sticking to this. Otherwise, it will fall down. So that means it makes sense for me to say that as g increases, a will increase. As theta increases, tan theta will increase, which means a will also increase. And that is what is called reality check. Okay. So after getting the answer, you have to ask yourself, does it make sense? Again, in this problem, they didn't ask you this, but I think I saw some other problem with this, asking this. Okay, so that is method 1. You may be wondering, sir, usually in inclined plane we will do mg cos theta and mg sin theta downwards. Why are you, confusing us with this? Well, if they say it's not moving, you can write it like this in the usual xy coordinates, or you can turn the forces along the inclined plane. Okay, you see, when I did this, I had to change only the normal reaction n. When I adjust it to the inclined plane, I have to change this mg sin theta, mg cos theta, and I have to change the ma also. Okay, I have to change it to this plane. I can show you that, and you will see that you will get the same answer. Absolutely nothing very difficult. Okay, so if you know sin theta, cos theta, you can do it. This is mg. This is mg cos theta. This is normal reaction n. This is mg sin theta. So up to this, I'm sure you don't have any doubts. But listen carefully now. The MA is acting horizontally because the wedge is accelerating horizontally, which means this will also be horizontal. F is equal to MA. But I have to turn it to this way. So that means I have to, this is theta, this is 90 minus theta. If this is 90 minus theta, this is theta. Okay, these are all the places where you will get doubt. So I am repeating one more time. Since this is 90 degree, if this is theta, this is 90 minus theta. This and this are 90 degree, which means if this is 90 minus theta, this should be theta. Once I know that, it's a very, very simple problem. For your benefit, I am showing it in different colors so that it will be easy for you. So F cos theta, and it will be acting downwards also. So it will be F sin theta. So now you have to forget about this mg and ma because it has been resolved into two components. Now you can equate the f's along the inclined plane. So you can imagine that these two is one direction and these two are in a vertical direction. So you can do it in either method. Okay, so don't get confused if you see some different methods in your solution books. So I can say n is equal to, this should be equal to these two things which is acting downwards. So f sin theta plus mg cos theta. Similarly, this and this should be equal because they said it's not moving. So f cos theta is equal to mg sin theta. Remember I told you this F is a pseudo force. They are asking you to find the normal reaction force N. Okay, this is very confusing in this problem. Initially I thought they are asking this, but actually they are asking normal reaction. So that means I want to find N. So F is equal to mg tan theta. Cos theta comes here. So mg tan theta. So N is equal to, in place of F I will put mg tan theta. Or you can put sin theta by cos theta. Nothing wrong, because I am seeing sin theta here. Plus mg cos theta. Mg is common, this will become sin squared theta. Cos theta will multiply here, so it will become cos squared theta divided by cos theta. Sin squared plus cos squared will become 1, so I will get mg by cos theta. So that means you will get the same answer in both the cases. Mg by cos theta is your answer. Mg by cos theta. Okay. So I told you many times, learning more than one method. Maybe you will say, sir, this looks easier, so why don't I follow this? Yeah, you can do that. But there are some situations where you may have to know both the methods. Okay. So I'm not compelling you, but whenever possible, try to learn more than one method. It will improve your confidence. And it's like a magic, right? Whichever method you follow, you get the same answer. And that is what science is all about. Or physics or mathematics is all about. Very easy problem. I can do it very quickly. Coefficient of static friction between the mass 2 kg and the table is given as 0.2. So that means mu is equal to 0.2. What would be the maximum mass value of block B? So they are asking to find the mass of block B so that the two blocks do not move. So that means you should know that immediately. You should know that tension is acting upwards here, mg is acting downwards here, tension is acting this way, somebody is pulling this way, and the friction is holding it this way because this is trying to move this way, which means the friction will try to act in the opposite direction. So F friction, so F friction should be equal to the tension. Similarly, tension should be equal to the mb into g. So mu into n is equal to tension. Mu into n, so mu into ma into g. So I can bring this one over here. So mu is 0.2, mass of A is 2 kg. G, I think it will get cancelled out. Yeah, so mb is what they are asking. G, so cancel this. So mb is nothing but 0.4 kg. Okay, so if you know the simple concept that this and this are equal and this and this are equal when it's not moving. Sir, why didn't you consider A here and A here? Well, the answer is if you want, you can write it. So I can write one more step if you want, if you are confused. So I can say sigma F is equal to MA. So T minus F friction is equal to, since they said it's not, block does not, do not move. So that means acceleration is 0. And that's why I said T is equal to F friction. Do the same thing over here. So you will see that T is equal to mg. Okay. So I'm just trying to tell you that this is a special case where acceleration becomes 0. But the basic ideas are still the same. Any doubts so far around following everything? So 26. 27 I'm going to leave it as a homework. 28 we can do it. Three forces acting on a body are shown in the figure to have resultant force only along the y direction. The magnitude of the minimum additional force needed is. This may look like a very complicated problem, but it's actually a very easy problem. What they're saying is the resultant should be only in the y direction. The x direction forces should cancel each other. So that means you have to add one more value. That's what they are asking. So that means this will be so that means this is nothing but 4. This is cos and this will be sine. So that means it will be 4 sine 30. This will be 1 cos 60. You don't following? Because this is 60 degrees, so 1 cos 60. 1 Newton cos 60. This one, it's not clear what is the angle, but you know that if this is 30, this should also be 30 because this looks like a straight line. So if this is 30, this side it will be cos and this side it will be sine. So that means it will be 2 sine 30. This is where many of you will make mistakes. So please think yourself, and if you have any doubts, please ask me. This is cos and this side it will be sine. This is cos and this side it will be sine, but I'm not interested in the y-axis. Similarly, this is cos here and it will be sine here. Sine 30 means 1 by 2, so 4 into 1 by 2, which means 2. This is 1 by 2 and 2, so 2 into 1 by 2, so it will be 1. This is cos 60, so cos 60 is also 1 by 2. So that means this and this should be added. So this side I have 1.5, right? This side I have 2, which means I need to have another half acting this way to balance this one. Only then it will become 0 in the x-axis. So that means half is your answer. Minimum additional force, so that means 0.5 Newton. If I add it or this side, this and this will be equal. Any doubts? This is also a lift problem. You can do it, acceleration upwards. Only thing you have to add the mass of the lift and mass of the person. So 940 plus 60 it will become 1000. Okay, so I will leave it to you as homework. These are all the kind of problems you will, many of you will find it a little bit difficult when you have, 2 or 3 masses. I have seen students confusing a lot. But if you follow the method, I'm sure it's all very easy. couple of different methods to do this. Let's see. Net force on the block of mass 2m. They said it's going at a constant velocity. Constant velocity means acceleration is 0. So that means sigma f is equal to ma, you can use it, but a will become 0. So listen carefully. This is where many of you will have confusion. You may have difficulty. So listen carefully. And as I said, many of the solution books, they don't show you proper diagrams at all. They just directly give you the equations without showing the diagrams. So somebody is pulling this way, and here the mg is acting, the earth is pulling it down, and then something else is pulling it downwards here, and that is your tension in the string. So I will call this as tension T1 in the first string. And similarly, this is held upwards because some tension is acting here. And this is acting downwards to mg, weight. Similarly, this tension is pulling it downwards, so I will call this as tension 2. And this tension 2 is acting upwards. And this 3mg is acting downwards. That's all. Any doubts here? This is where many of you will have confusion. If you know how to write this, the problem is over. If you don't know how to write this, you cannot do this problem. Many of you will have a confusion, sir. Why are you writing T1 here and T1 here? Well, the tension, the rope is pulling this mass downwards, whereas the same rope, this mass, it is actually pulling it upwards. So that's a confusing part in the rope. So that means with respect to the mass here, the tension is pulling downwards. With respect to the mass over here, the tension is acting upwards. This F is different from this F, so don't say, sir, writing this one. This is from the formula. This is given in the question. So that means F minus mg minus T1. Mass into acceleration. I told you constant velocity means acceleration is 0. So that's the equation for the first block. So I have to draw this separately. This will be separate like a free body diagram. This will be separate. So, but here I can show it together. So same sigma f is equal to ma. So T1 minus T2 minus 2mg is equal to 0. If this is going at a constant velocity, they should also be going at a constant velocity, right? Because all of them are connected with the string. The equation for the last one will be T2 minus 3mg is equal to 0. That means T2 is equal to 3mg. That means I can put it over here. So I have to work backwards or no upwards. So substitute this over here. I will get T1. Once I get T1, you substitute over here, you will get the F. You see, they are asking you to find the what is the net force acting on the block. Actually, I thought they are asking you to find the F, but they are asking you to find what is the net force on the block of here mass M. So the net force acting here will be 0 because there are a lot of forces acting. The net force is going to be 0. Yeah, you see the option is there, which means I don't have to break my head with all these things. Any doubts? I thought they're asking you to find the F here, but now I realize that sometimes we'll be assuming something and we'll be doing the problem, but reading the question again will help you to do it correctly. Any doubts? So if I want to find F, I can still do this. Substitute this over here. Okay, so from here this is going here, from here this is going here. So that means we are working backwards. So F is equal to 6 mg, but that is not required in this particular problem. Okay, so we may get a wrong impression that they are asking you to find F, and we may choose the 6 mg, which is wrong. Because they said, if they said what is the F force F means, I would have said this one. They said net force on the block mass 2. In fact, the net force on each of the block is 0, because here also it is 0, here also it is 0, here also it is 0. Okay, you see, net force is 0. If you are wondering how is that possible means, you should know that constant velocity means acceleration is 0. Acceleration 0 means net force is 0. Whenever you are going at a constant speed in highway, that means the net force is 0. The forward engine force and the backward air resistance and friction both are equal, and that's why you are going at a constant speed. If you are accelerating, it means the engine's force is more than the frictional force which is acting backwards, okay, or the air resistance. A balloon with mass m is descending down with an acceleration a. How much mass should be removed from it so that it starts moving up with an acceleration a? So, bit challenging question, so please pay attention. A lot of concepts to be understood here. So, balloon means I will assume something like a hot air balloon, right? So, people are sitting here. So, that is what they mean by balloon with mass m. descending down, so that means it is coming down with an acceleration a. You see, you must have seen it in some YouTube videos or something. There will be some kind of a gas, hot gas filled up in this thing. So you'll have a pump here, so it will be blowing some hot air here, and that is what will keep the balloon going upwards. So actually, there will be some F upwards, and the weight is acting downwards, M into G. So as usual, I will say sigma F is equal to MA. So F upwards minus mg is equal to, don't forget there is a minus ma. Downwards means minus ma. So what this means is, even though you are putting some gas, just giving some F upwards, this is actually bigger, so that means it is descending downwards. So this will come on this side, so mg minus a. Now read the question. How much mass should be removed from it so that it starts moving up with an acceleration a? So that means this is what is actually pulling it down, which means the mass is very high. That means I will say, okay, some of you get down. So I will say 2 or 3 people, I can push them out. Well, I'm just joking. You cannot push them out if you are at a higher height. But if there is some sandbags, right, that's what they do. There'll be some sandbags and you can push out the sandbags. That means you can reduce the mass. So they're asking how much mass should be reduced so that it will start moving up with an acceleration a. So you see, not a easy problem. Okay, so you have to think a lot. There is no change in the F upwards or in the engine. So that means the engine is still going to give you the same force. But now the mass has been changed, so that means I'm going to call this as m dash. This is a new mass, new reduced mass. Acceleration a. So read the question. Moving up with an acceleration a. So this is what we want. That means do the same thing. Most important formula in mechanics, sigma F is equal to ma. So F upwards minus m dash g is equal to m dash a. Why I didn't put minus? Because now it's going upwards. Here it was coming downwards. So m dash is your reduced mass. Okay, after some sandbags have been pushed out. So how much mass should be removed? So that means they're asking you m minus m dash is what is asked. So how do I find that? I need to find m dash. I can equate f upwards, right? Any doubts? Somebody asked something? G minus A. But as I said, f upwards, it's same. So that means I can equate this and this to find m dash. Once I find m dash, if you choose this option, it will be wrong because they asked you how much mass is reduced. So this is the final mass. So that means they are actually asking f m minus m dash. Okay. So if you have this clarity, you will not make any mistakes. Otherwise, what will happen is you will find M dash and you will choose the wrong option here. Did I make any mistakes here? Minus G. G minus A is correct here, and here it will be G plus A. Okay, nobody is correcting me. Because this minus will become plus, so G plus A. And I cannot cancel M and M because now it is different mass. This was say 10 kg, now it's like 5 kg. So I cannot cancel directly. M dash, find it out and subtract it here, you will get the answer. Once you get the hold of it, it's very easy. You can do it very quickly. So I can take M commonly out. G plus A, G and G will cancel. So A minus of minus, it will become plus. So I think it will become 2A divided by G plus A. So 2MA divided by G plus A is the answer. Even if you miss any small step, everything will go wrong and you will get stuck and you will not be able to do it. So that's why I'm just going very, very slowly, step by step. Okay, if you know the concepts, the speed will come automatically. If you don't know the concept, some people will say you have to finish it in 1 minute, 1.5 minute, 2 minute. All these things are secondary for me. In my opinion, if you know the concepts, you can do it. If you don't know the concept, you cannot do it. Very simple. Okay. As you keep on practicing, initially it will take 5 minutes and then it will take 2 minutes. After 6 months of practice, it will become 2 minutes. After 1 year of practice, it will become 1 minute. Okay. So speed is just a matter of time. As you keep on doing it, it will improve. But right now, you are supposed to be focusing on the concepts. Okay. If you know the concepts, yes, you can do it. Okay, so I think it's already time. So we have reached 31, not bad. So last class I think we stopped around 15 or 16, so we have done another 15 problems today. So my expectation is keep trying these problems, okay? If you try it and then come, you will learn more. If you just come directly without trying it out, you will learn only say 50% or something, okay? But try it and come, you will learn 100%. Okay, I think you have up to 63, 64, 65. Okay, we have reached only 31. So 50% you have completed, but still it's a very, very important chapter and very easy also, right?